So let's talk today about WebSockets, which is a really fun topic. We'll talk about the HTTP protocol. We've talked about that before. Really, it's what we deal with all the time and how that evolves into WebSockets. A bit of a history about how that worked. And then how we program WebSockets using libraries. Then we'll build ourselves a little multi-page React app that does some WebSockets. It'll be a little web chat program real time. Anybody during their midterm project worked on the messaging? We had to send a message to somebody else and get the message. Remember that? That was kind of fun. And we probably did it through something like databases where you saved the message and then the other person would fetch the message. But it wasn't really real time because you would send them a message, but you had to wait until they actually looked for their messages. So it's more like email in that respect. But WebSockets is true real-time communication. I'll talk about all the fun things like events and how to broadcast messages to everyone in the group and all kinds of fun stuff. Surprisingly easy, as it turns out. So let's talk about the HTTP protocol. The HTTP protocol. Okay. And we know what this is, right? This is request response. And response. Spell that right? Yes. And it looks like this. We all know this. We've seen this before. You have the client who makes request to the server and the server responds. This is old stuff. You want something else? You make a second request and the server responds. Oh, this is great. And this was how the web originally worked. You had servers and you had clients, and clients would do stuff. Somebody would click on a hyperlink. I love that term, hyperlink. It sounds so cool. In fact, let's take a look. I think I've got it here. Let's pull it up. The HTTP, look at this, the hypertext transfer. It sounds like a spaceship. The hypertext transfer protocol. Wow. This is 1999, turn of the century. Wow. So this is the protocol for all things hypertext. They name things. It's like they used to make cars look like rocket ships back in the 50s. Well, everything was hyper back in the late 90s, I guess. And this describes how that protocol works. There. And it's a long document. This is just the table of contents. Wow, look at this thing. It keeps on going. Oh, there, finally. Okay. So it is made to describe how HTTP is supposed to work. And the point is, this is what's called an RFC. It is a quasi-legal document, if you will, that if you are a browser developer writing a browser, you must comply with this document because it is a standard. And you can't say that you are a HTTP compliant browser unless you do comply with this document. That's kind of the rules of the internet. So, or you can't write yourself a server unless you comply with this. So, although it's not a truly legal document, if you don't follow it, no one's going to use you because you're not compliant. And you can't claim that you are compliant. So browsers must comply. Every single browser in the world must comply to this standard. And that's how these RFCs work. Okay. And it describes how we do requests and responses. Wow, a lot of stuff. Now, of course, this worked great back in the day when we just had a bunch of blue text and you clicked on it and you got more stuff with blue text, hypertext, that, and hyperlinks. But it didn't lend itself very well to real-time experiences. Back in the day, we had games, but boy, did they suck. Had a page, it was like Tiny App. You click, the whole page reloads, and you get a new page for your game. Yeah, how much fun was that? Actually, they had some pretty cool games. You had to use a lot of your imagination because nothing was moving on that screen. Once that page is loaded, it's there. and then you had to load another page and maybe you got more stuff. Okay. So, and that's all you could do. The server cannot respond unless there's a request. It can't do anything. So if that server has something really important to tell you, it can't. It can't say, oh, someone's coming at you with an axe. You can't do anything until you go request. Oh, sorry, you died. Couldn't tell you. So obviously not the best for real-time games. So we need some solutions to this, right? How to achieve more of a real-time experience, because that's the ultimate goal, is how to get real-time experiences in browsers while still following HTTP, because that's what they're compliant, or they have to be compliant. Okay. So what happened was a little later, they had this thing called JavaScript came out around 1995 or so. JavaScript browsers came out and we could do stuff on the page. You could make the page do stuff without loading the page. It was like a dynamic page. Very cool. Scared the crap out of people. Like, what? My page is moving. Ah, what's going on? It's like the old days of telephones. People wouldn't touch them because they're scared of them. Well, when JavaScript first came out, believe it or not, it freaked a lot of people out. Their page started moving and doing stuff without loading a new page. And as you can imagine, people didn't like that sometimes. So they added the option in your browser to disable JavaScript, and that option is still there today. By the way, you can disable JavaScript in any browser. And of course, nothing works today. But back then, people weren't too happy about programs running in their computer. So we had JavaScript, and then a little later, we came up with this thing. I'll paste it in because it's a little long to type. It's called this, the XML HTTP request. What is that? And that was actually developed by Microsoft. Interestingly enough, for Outlook Exchange email. So you can get your emails in real time. Instead of having to check for emails, you could be notified right away. Oh, you've got an email. That was very cool. Okay. And that was for Exchange 2000. So this happened around 1999, real turn of the century stuff, year 2000. Okay, so, but what is this? XML HTTP request. Part of the word XML, because back in the early 2000s, everything was XML. If you had X in front of a name, you could sell it. X Files was popular. People loved the letter X. I don't know why, but there was literally X in front of everything back in those days. So what we had was this became the underpinnings of another technology which came very, very closely, and we probably know it by a different name. In fact, have you seen the term XHR anywhere in your browser? You've probably seen this in DevTools, console log XHR. That does stand for XML HTTP request, and you probably know it by its more friendly name, AJAX. That's what it stands for. Okay. And that was incorporated into browsers around between 2002 to 2004. They all started jumping onto Ajax. I was around at that time doing stuff, and Ajax was hot. Like, look at this. We can do mini requests inside the browser using JavaScript. And of course, JavaScript lets us change the DOM. And now these Ajax things let us talk to the outside world and change the DOM. This is fantastic. We can have much more real-time experiences in the browser. It was very cool. Okay. And of course, we still use Ajax today. But the problem is with Ajax is what? It's still a request response, isn't it? There's no difference. You still have to send a jQuery get or jQuery post and wait for response. It's not real time. It just allows the page to move in response to these little mini requests, which is a heck of a lot better than reloading a whole page every time you want to swing your sword. So course, game developers and real-time developers, being the very innovative people that they are, they discovered a way to make it work. So let's go back to this big, long document. Now, this does describe how HTTP is supposed to work. It has all kinds of rules, things you must do. You should do this. You must, you should not do this. You may do this. Option. There's a lot of these terms, right? If it's a should, you got to do it. Like, I don't know, should not. These and must. These are, you have to do this. And there's a couple of mays and optionals. But the interesting thing about this document, and that was discovered early on, it does describe this. You have to do it this way. There must be a request. There must be a response. And they have to happen kind of in that order. But it doesn't talk about the timing of the request and response. You can start a request. The response can happen, but it says it doesn't talk about that the request has to end before the response is sent. It doesn't say the response can't respond again and again and again and again, and the same request. They can keep on going. In other words, you can keep this connection open and to have one big long request and one big long response. I could do it like this. There. It's called long polling. And this document doesn't say anything about that. It's not illegal. You know, people love finding loopholes in laws, don't they? Well, this was a loophole. Didn't say you couldn't, so we did. And this became the de facto standard for games for a very long time, this HTTP long polling, where they keep the connection open, just have a big open request and one constant response, and it looks like real time. And so it was called long polling. In other words, they hacked HTTP and had this thing called long polling. It had another friendly name. It was called Comet. You might even heard that term, Comet. It was a huge thing around the same time, around the 2004-5 time frame. Comet came out, and the response request streams were just kept open. And as you can imagine, hugely popular. Because now you can have actually real-time games and stuff. And around this time, this 2004, 2005 timeframe, games just exploded on the internet. Remembers that? There were just games everywhere. All these companies sprang up, producing just tons and tons of games. It was like the golden age of games on the internet, this whole time frame. This was like 20 odd years ago, right? But it was a big deal. So Comet became huge, huge. It was a de facto standard. It wasn't really a standard, but people were using it. So it just became what people did because it didn't say you couldn't. Okay. And although this is great, it worked fantastic, it did introduce a quite significant problem for everyone. Okay. And why? Well, it was a hack. It was still a hack. And although it didn't violate this document, put yourselves in the shoes of a browser developer or browser company or a server company who's developing server software, anybody who's writing a commercial product now for the internet. So you have to know you follow this. This is the law. Sure. But also you got to keep in the back of your mind, yeah, but there's this Comet thing. We've got to be really careful. We don't do anything to also break Comet. So you've got this official document and this unofficial, everyone knows about it, Comet thing that you also can't break if you update your browser. Because guess what happens to your browser if you break Comet and nobody's games work? Who's going to use your browser? Nobody, right? So it wasn't official. This was the official document. It's like, but we're following this. Yes, but there's Comet and you have to follow that because everyone uses Comet. So it became a problem, right? We needed a real solution. So we needed a real solution. because Comet wasn't it. It was just a hack of HTTP. It was never really, the HTTP was never really intended for this. AJAX wasn't supposed to be this long polling thing, but it worked because of a bit of a loophole. So 2008, a little bit of history lesson here. They started work on a real standard. There. Okay. And in 2011, the WebSocket protocol came out, was released. Very cool. It's RFC 645. I have it memorized now. 6455. A huge shift in the internet. The website, I know it's silly, but this was a big deal. The WebSocket protocol came out. Let's take a look at this RFC. I know you're dying to see it. It's just so interesting, I know. Okay. There we go. The WebSocket protocol talks about all the cool stuff. Okay. Not quite as much of a document, but it's very cool. Okay. So it talks about the history, right, of why we're doing this. Because, yeah, you had to open connections, had high overhead, maintain mapping. It was nasty. So they talk a bit about the history, why this happened. It was released in December 2011. So then the first browser came out with true web sockets. Who wants to guess what the first browser was that had real web sockets baked into it? Chrome, Netscape, Chrome. It was Chrome. Chrome 4. Yes, there was a Chrome 4. Single digit Chromes. Wish it was Firefox, but unfortunately not. It was Chrome 4. Google produced the first browser with true web sockets. And as you can imagine, also hugely popular because it was a huge, huge deal. And that happened, guess what year it happened in? 2010. Wait a second. Let me get this straight. So they started in 2008. It was released 2011, but somehow in 2010, Google released Chrome 4 and beat everyone to the punch. Now, how could that have possibly happened? Let's take a look. Let's look at the WebSocket protocol. And who were the contributors to the WebSocket protocol? IFET. Oh, look, Google Inc. They were a big contributor to the WebSocket protocol. Now, you wouldn't think that they'd perhaps tried to jump the gun and release their browser before the protocol to get some kind of advantage. They wouldn't have done that, would they? Of course they did. Of course. They knew it was coming out. And they released their browser before it was released. So Google had a huge competitive advantage. And everyone else after 2011 when it was published, all the others, but by then it was just too late. Chrome had been around for at least a year and had pretty much scooped up the entire market for WebSockets. Okay. And it's still very popular today. So it's important to note that the WebSocket protocol runs on top of HTTP. It's not its own protocol. It's kind of a superset or an extension of the HTTP protocol. That means it inherits pretty much everything. The port, the security like SSL, TLS, really everything. If you can make an HTTP connection to something, you can make a WebSockets connection. So there's no worries about things like firewalls and ports. I remember talking to a lot of the server people when we proposed some of these options in businesses and at work, and we'll say something, oh, well, we could use WebSockets to this. And as soon as the network people hear the word socket, they literally freak out and they think, what? No, we can't do that. We have to open up firewalls and networking and VLANs. We can't do it. You have to talk them down from the edge. or from the ledge, right? Say, no, hold on. No, this is just HTTP. You don't have to do a thing. Don't worry. This is all HTTP. And it is. It rides on top of HTTP. So everything's inherited. The authentication, all the cool stuff, it's all really the same. It really is just an upgraded HTTP connection. That's what it really is. So what does that mean for us? I mean, this is all fun stuff to talk about at parties and become popular, I know. But what does it mean for us as developers? Well, of course, we use libraries as developers. And there are a number of different libraries we can use. There's the WS library. It's a little bare bones. It's very, very common. There's another one, which I can't type it because it's got a funny character in it. There's this one. It's very fast. What's that character right there? Anyone know they're Greek? What is that one? Sounds like a Pokemon, doesn't it? Mew. Exactly, Mew. Mew. Yes, it is a Mew WebSockets. Okay, it does sound like a Pokemon, doesn't it? And very fast, a little on the bare bones side, but it's really fast and really used a lot for really games that need a lot of high speed. There's another one we use, which is called Socket.io. Anybody heard of this one? You probably heard of Socket.io, haven't you? This one is huge. This is probably still the most popular still. It's been around a long time and it's really easy to use. It's easy, it's pretty fast, and it supports pretty much everything. Pretty much anything. Any browser, you name it. It has often been called the jQuery of WebSockets because it does support pretty much everything, all the browsers. And as we'll discover, it actually looks a lot like jQuery. It really does. And we'll discover that as we use it. You'll notice this and look at this and you'll say, wow, this is actually pretty familiar to me. If you've coded jQuery, you've probably seen the same patterns you'll see in Socket.io. Okay, has some really cool features like auto reconnect, really cool feature. Okay, and custom events and other really interesting stuff. It's been around a long time, but it's still popular. And to indicate how long Socket.io has been around, it supports Comet still. It's been around that long. In fact, it was the library that people used for Comet. It started off as a Comet library and they just evolved and became just so popular. And as you can imagine, a developer simply just keeps using Comet. So they keep using their Socket.io. Their code barely has to change. It was great because the developer uses the library. And if a protocol needs to go to WebSocket protocol, it still works because your code doesn't have to change that much, if at all. So people loved Socket.io. They just migrated to WebSockets and kept working. So how do we use WebSockets? What do we do with WebSockets? Let's take a look. Let's go to Socket.io. Socket.io. Okay, Socket.io, very cool. Okay. Not bad documentation. You'll find it's actually pretty well documented. Getting started. I want to get started. What do I do? Okay, so you can talk to what you have to do. You have to make yourself a server. So you have to add this to your code. Okay, there we go, integrating Socket.io. So what we need to do is, since WebSockets runs on top of HTTP, you probably want to put this on top of an existing HTTP server, such as Express. And that's the example they give us here, how to use your Express library. So We use Express, and then we put our socket IO on top of our Express. And they're telling us how to make an Express app, which of course we already know. App equals Express. They got this funny thing here, and then they got our dot listen. So kind of the same kind of stuff, right? Let's go ahead and look at what we have here. I've got myself a little app here. There. This project, it's really two in one, or two projects in one. I've got an Express app, and I've also got a React app, and they are two completely separate apps. They're not related in any way other than they're in the same directory. And so my Express server app, I've got one file. It is the world's smallest Express app. Doesn't do anything, does it? Well, I could put maybe, an app dot post. Maybe I want to listen to a login slash login, or maybe API slash login to be more precise. And then got my, was it RAQ and my response. And I'd maybe set a cookie or a session or whatever. Just some typical Express stuff, right? Okay, so this is an Express app, and they tell us how to convert this into a Socket IO app. So we need to install Socket IO, which I've done. I've got, where to go? Right there. So just npm install socket.io on the server side. It's pretty simple, and I've done that. And look at Socket.io. It's okay. So we have to first off do this. You got to require this server thing. So I'm going to do that. Let's copy that. That looks pretty reasonable. Okay, and I will paste it right in here. I'll put it here. Let's go ahead and start my app. It's going to work. There's my app, Express Server. I'll go npm run. Do I have a local? Let me take a look. I've got a nodemon. I do. Run local. Nodemon. Okay. Much easier. Run local. Oh, there we go. It doesn't do anything, but it started. I'm always happy about that. So what do I do now? So now it says you have to make this server thing here. What's with that? So, and then they say you use the server to create your IO with that. Okay, so it looks like I have to do this and make a server out of my Express app. Okay, we can do this, but turns out there's actually an easier way than this. This works fine, but there's actually a much easier way than doing this. Because in order to make our IO, we need this server object. And they tell us to make a server object out of our app from Express. So we need this line here. So let's take that line right now. I'll put it here. Okay. Well, as you can imagine, my Express app's not going to like that because, of course, server is not defined. So where do I get the server from? So they recommend I just make one out of my app, and I have to acquire this node HTTP library. But turns out I discovered there's a much easier way. The listen. Guess what it returns? A server object, just like that. There. So now, let's look at there we go. And now this is a WebSocket server. That was it. One require, add a variable, and one line of code. And now my Express app is a WebSocket server. It is now listening for WebSocket connections. That's it. That was pretty simple. This is not hard stuff. Okay. So now what do I do? Well, now I need to go to my React app or my client and have it connect. So I've got this little app. It's nothing to it. I've got a little page here and it pulls up a component. I've got this component called chat. There it is right there. Okay. And there is my chat component, and I can just create it and destroy it like this. take a look at this. So right now there's WebSockets, by the way. What's going to happen is our client does what's called an initial handshake. This is the WebSocket protocol. It's called the handshake. It is a standard or mostly standard request response where the client says to the server with a request, hey, I'd like to establish a WebSocket connection with you. And the server will say, sure, that sounds good. And then they proceed to establish this connection. So this is a regular request response. And then they've got this full duplex connection, which just means two-way, where anyone can talk at any time and nobody has to wait for anything. And that's how it works. Okay. So my little app right now looks like this. I've got my app and these two components. I call them pages, but they're just components. I'm just got a conditional rendering. If there's a login, it just shows to page. So this is the one we're going to work with, this chat page here. And that's what's happening. I've got just, if they're logged in, I show the chat page or the chat component. If not, I show this login component. In React apps, although some apps may look like multi-page, they're just conditional rendered components. That's all they are. That's the way every React app pretends to have more than one page. It's not real. It's just another component disappearing and another one taking its place. It just looks like a page because it's big. There. So there's my chat page right there. We're going to turn this page into a chat or a WebSocket chat component. Okay. So we have to, in our client side, we also have to import Socket.io. And this one is called Socket.io client. And I've done that already. npm install Socket.io client. Okay. And to use it, we have to just import it. Let's go to my chat. This component does nothing, as you can see. So I'm going to add a quick import like this, IO. And let's go ahead and try to start this thing. Oh, it's running. And it noticed, okay, it didn't crash. So it found my installed Socket.io. Okay, so now what? What do I do? So to connect to the Socket.io server, it's pretty simple. We just go const, give it a name. You'll commonly see it called socket. That's just the usual name. Equals IO. That's it. There. They are now connected. That was kind of anticlimactic, wasn't it? But it worked. It now connected. Let's double check. Let's watch what's going on. Let's go to our dev tools. Anything happening here? Let's take a look. And refresh our page. We'll log out and, well, looks like stuff is happening. Look at this. Wow. What's going on? Let's look at my network. Oh, got all these connections. I've got a whole bunch of them actually. What's with that? So it looks like something's happening here, isn't it? Okay. And we can actually look at this. And what is this? What is this 101? So remember we talked about that initial handshake? This is the GET that initiated the WebSocket connection. It's a GET. And let's take a look. There. It returned a 101 switching protocols. What does that mean? I don't know, but it looks kind of cool. It looks like we're switching protocols, which means the client and the server have agreed that they will now talk in some other protocol, in this case, WebSocket. Okay. Now, you also probably noticed I've got an awful lot of traffic going on here, like just tons of it. Way too much. So I've made a big mistake, haven't I, in my React app? What am I doing here? This is a Socket.io app. Oh, the question about the proxy. Is there no need for proxy? Yes, you must still have a proxy. So in other words, this IO, I could put an absolute address here if I wanted to, but that it's like a fetch or access that way. This tells the React app to go back to your own server and make this request. So I have, of course, added a proxy line or someplace. I've added this. So what the proxy line, at least in this format, does, it tells the React server or the Webpack server in development mode to, if you see an AJAX call, send it here. So you have to have a proxy. You wouldn't have this in production because there is no server in production, okay? Or at least not a Webpack server. But for development, this works. This line says IO with no parameters, says go back to the server you came from and try to establish a WebSocket connection with that server. And of course, we have the proxy line, which says, well, if you see a AJAX call, send it there. Okay. But I have all these. What's going on? What's happening here? So, of course, what's happening is this is a side effect, right? This is going outside of React. This is telling the browser to do something, just like a set interval. I've told the browser to do something that React doesn't know about. It is the browser making the WebSocket connection, not React. And even if I go back and change pages, that connection still sticks around. It just makes another one. Now I have more and more WebSocket connections. So as we know, this has to be wrapped in something, doesn't it? What do we think? What should I wrap this thing in? Because this is definitely going outside of the browser. It's doing something that React doesn't know about and it can't clean up. And yeah, a use effect. It must be inside a use effect. There we go. Let's put it right inside there. There we go. Okay. Look at our network tab now. So let's go here. And now, not so many. We get one of these and then a bit of traffic. Just a little nicer. Okay. So now we have a WebSocket connection. And we can now have our server and our client talk to each other. Back to my console. There we go. Okay. So now we have a connection, but how do we know? So now we can start talking about what are called events. Remember in jQuery, we had all these events? Remember on input, on submit, on click, all this stuff in midterms we going crazy with? jQuery is fun. I like jQuery. I love jQuery. It's awesome, right? You can do all kinds of cool things with it. So we want our server to know when somebody has connected. So to do that, I need to add a listener. It is a listener on my server. Okay. IO, and it's going to be IO dot on. Remember this? Remember snakes? We had the con dot on connect, on data, all these ons. Well, it's the same thing. It's IO dot on, and we're going to look for or listen for a connection event. And when we get one, we get some stuff, and then we're going to do something. Yeah. The same pattern as before. Just like snakes and just like jQuery, on the name of the event and then something. And we're going to console log. Let's just console log. Someone connected. An exclamation mark because we're so excited. Someone connected. Let's take a look. Let's go to my server and it says someone connected. Look at that. Let's log out and log back in again. Someone connected. I'm so excited. Spoiler alert, this is about as hard as it gets today. This is it. It doesn't get any harder than this. We have now learned almost literally half of what we need to know about WebSockets. Dot on is a big part of it. There's really only 1.5 more things we need to know about WebSockets. We just play the rest of our time. Okay. This is great. Someone connected. Okay, so, well, how about let's find out if someone disconnects. Not a bad thing to know too. So what we get back an object. It's oftentimes called socket, but that's going to confuse me because I called my client side socket as well. So I'm going to call this my client instead to let me know that this is the client object that I got back. So when someone connects, an object is created for that client, and everything for that client now happens inside here. Because remember, this is a server, and servers can have multiple connections all happening all at the same time. So everything now is about this client. And we get a big object. We get something called the client ID. Take a look at that. And it is a random string, some kind of UID that identifies that client. Now, important to note about client ID. It's a string, which is great because you can use it, all kinds of cool things, but it should never leave this file, ever. It should never leave the server. It should never be saved anywhere. Definitely. It should never put in a database, never sent to anybody. It is private. The reason is it can change at a moment's notice. Look at that. It changed on me. So you would never save this. You could never use it as an identifier for a user because it can change, just randomly just change on you. Now it'll exist within this block of code. You can rely on that. But apart from that, it might change. Okay. So let's go ahead and detect if someone is disconnected. So it's going to be now client dot on. It's not io.on. Be careful of that. It's client dot on. We're going to find out if somebody has disconnected. So we'll look for a disconnect event. Connect. There. There. And we'll console log someone left. Sad face. There. Okay. Someone has left. Someone connected. Someone connected. Got two of them. Now, why is that? That looks kind of odd. Didn't expect that. Try it again. Where's someone left? It's kind of weird. I'm getting all these connected. Let me refresh my page quickly. Whoa, I got 4 someone lefts. Uh-oh. What's going on here? Now, we talked about this earlier. Remember, we talked about our use effect. Remember, we set an interval and we kept on setting interval every time and they stacked up? Well, that's what has happened with our app. Every time our chat app has been created, it makes a new connection, but it never disconnects. Remember, this is a permanent change or a persistent change to our browser. As long as that browser page is there, that socket is open. We create a new one. Now we have 2 or 3 or 4. We need to clean up after ourselves. We need to clean up. And when this component is unmounted or destroyed or goes out of scope, we need to make sure that connection disappears. And we know we do that by doing what? We return from use effect, return a function. That's pretty simple. We simply tell our function to return, and I'm going to have it return a socket.connect. So return, and it returns a function, and that function is executed when the component is destroyed or unmounted, as it were. Okay, and we're going to simply say client or socket rather dot disconnect. There. This is important. Don't forget this. If you forget this, you're going to have connections like crazy. You're having crazy. So here's the basic pattern. Use effect, connect, disconnect on the return. That's kind of your basic WebSocket pattern. Okay, let's take a look. Let's go to our server. Okay, so now we're going to connect. Someone connected. Someone left. Okay. Try it again. Someone connected. Okay, we're in business now. So now we can detect if someone arrives and someone leaves. And you notice, look at that, different ID every time. Okay, because every time someone connects, they get a new ID. And not only that, remember we talked about some of the cool features of Socket.io? Let's go connect here. We talked about this thing called auto reconnect. Now that's something you don't get for free in a lot of libraries, but with Socket.io, you do. What does that mean? Well, remember, this is now a persistent connection. Well, how reliable is the internet? Things don't stay up all the time, do they? Stuff can happen. Things can have a glitch, or maybe some pulls a plug someplace, or kicks a cable, or just static. Who knows? As we know, the internet connections can go up and down all the time, and well-written software handles that, so we don't even notice it. I'm sure that even during our conversation in the last 45 minutes, at some point something has happened between myself and all of you. We didn't notice it because the software probably handled it gracefully. Well, let's look at Socket.io. What happens if my server goes down? There, I just killed my server. What's going to happen? Okay, let's go back up again. There. Okay, server's back up. What's my app going to do? Oh, it connected. So auto reconnect. My client connected again with a different ID. I think it checks every second or so. It's pretty efficient. So as far as we're concerned, we don't even worry about it, which is great. With other libraries, you do. You have to consider, is the connection still there, and maybe check and then do a connect. And that's a bit of overhead. Socket.io just makes it easy. You don't have to think about it, which is really cool. Okay, so let's go ahead and have our client now detect if someone connected or it connected. So what I want to do, I'm going to have a socket dot on, and I'm going to say when the connection is established or when there's a connect. So on connect. Now it's not on connection like the server. It's on connect. That one got me quite a few times in the past. Okay, and I'm going to say there. I'll just console log connected. Okay, let's look at my DevTools. Connected. Look at that. Log out and log in again. Connected. Okay, let's take out some of this. That's all my gets. I'll just take those out. There we go. Okay. Connected. Log out. Log in. Connected. So now on both sides, I can detect what's happening. So let's take a quick 10-minute break, and we'll come back and we'll start using this, and we'll learn the other half of what we need to know about WebSockets. So I'll see everyone in 10 minutes. See everyone soon. Cool. Exploding pineapple. So we started off with just listening for events. Just use .on, just like jQuery does. And the question is Socket.io used for chats with bots as well? Yeah, it's WebSockets. It'll be the same thing, exactly. In fact, we're going to do exactly that. We're going to have a bot do some responses for us almost right away. What I want to do right now is have my server, when somebody connects, I want to send them a welcome message, such as welcome to the server or something like that. But before that, I want to, because I'm getting kind of tired of looking at my console logs, what I want to do instead is list my messages here. I want them rendered in my React app. And that's pretty straightforward. I just need to make a list or something. So I'm going to make myself a list in my chat app. I'll put it I'll put it here, right at the end in my chat app. I'll make a UL right here. UL. There we go. Okay, and I'll render some kind of list. So I need a list, which means I need to have some state that'll hold my messages. Let's go ahead and make myself some state. New state. I'll call it messages. Good name as any. And set messages. And let me import new state. And it's going to be an array. There. Well, so far, so good. How's it looking? No crash yet. It's always a good sign. And I'm going to map these messages into a bunch of LIs. So I got to make myself a list here. I'll say const list equals my messages dot map. And for every item, I'm going to render an LI. There, that's pretty simple. And I'll just put the item inside that there. It's just going to be a bunch of strings. I don't really care about this, so that's almost good enough. I want to have my server send me a message. Let's go to my server, and we're going to have it when somebody connects to it. We're going to send them a quick message like welcome or something. So right here, when somebody connects, we're going to send a message. So remember I talked about there's really just two things we need to know. One of them is dot on. The other one is dot emit. We send. This is called emit, to emit a message. Okay. We can just send some text. Hello. And this is the simplest kind of an emit. But Socket.io has this concept of custom messages. By the way, if you simply give it no or just one parameter, it'll send this emit or this message to the client with a message type of message. It's just a standard message type. And you can probably guess on the client side, they go dot on message. That works. But generally with Socket.io, because it has this awesome concept of custom messages, we can give it a specified type and give some arbitrary type. Remember in jQuery, we can do what's called trigger. You can trigger custom events. Well, it's the same thing with Socket.io. You can send an event type. It can be called anything. My event. It really doesn't matter. We're going to call these system only because it's kind of a cool name. It means nothing. I'm going to send a system message. This means that the system, maybe server is even better. No, I like system better. It means that the server is saying something. It's not somebody else. This is the system sending you a message. And you can have different kinds of message types. A system message, a message from a person, a message from something else. So this is a message that is coming from the system itself. It's going to say, I'll say welcome. Welcome. Or welcome to the chat. There, welcome to the chat. So now we've emitted a system message. Okay, go ahead and don't see anything. Let's take a look. Well, nothing yet. Why is that? Well, the fun thing about WebSockets is when you do something on one end, you have to do the corresponding action on the other end. So I'm sending these system messages, but in my chat, I'm not listening for them. So I need to listen messages. It's going to be socket dot. Who wants to guess? Socket dot on. Socket dot on. And if I get a message type of system. Once again, that's an arbitrary name. There, data. And remember in snakes, that was on data. Same thing. We just call it system. We could have called it data, but I wanted to give it a more specific name, so I called it system. Socket on system. If you get a system message, then do something with it. Okay. So what should I do? Well, I'm going to add the data I get to my messages array. So set messages to a new array with my ... my old messages and the data. Yes, let's render my list. Here we go. Welcome to the chat. Yes, we have message from the server. Very cool. So this allows the server to send. And as I mentioned in Socket.io, there's really only two things we need to know: emit and .on. Everything else is extra. There is a cool cheat sheet that we can use. It's called the Socket.io cheat sheet. Let me try and find that for you. It's right, where'd that one go? There. There we go. The emit cheat sheet. How to use emit. And there's all kinds of emits. We use the basic emit. We said emit and we gave it some parameters. In this case, we gave it an event type and a thing. There's other kinds. It's what's called a broadcast emit. This says send to all clients except this one. This means send to this client, this socket. This one means send to all clients except this one. That sounds like fun. Let's go ahead and do that. Let's send a broadcast message to everyone else that's saying that someone has joined. So why don't we say, let's copy that was broadcast emit. So I'm going to say client dot broadcast dot emit. Same thing. Send the same message. There. And we'll say someone joined the chat. Cool. Okay. So if we log out, okay, we got the welcome, but we didn't get the someone joined. That's interesting. Why not? Well, because that's us. Let's open up another browser here. We'll take that, copy it. Now we have two of them. Is this going to work? It did. Interesting, funny behavior there. Let's try that again. It's replacing. So this is a classic case of something with state. It's working, by the way. It's all working. But why on earth, welcome to the chat, if I log out and log in here, it's replacing this. What on earth could be happening? This is a classic case of stale state. Remember we talked about this? Stale state? We have state that's gone stale in my chat.js right here. My set messages is my old messages. What's happened is it's set it before. So how do we get around stale state? Remember this one? How do we handle stale state? Yes, using prev, exactly. So we go set messages, we go prev arrow and ... prev or prev and spell it correctly there. Okay, let's try it again. Log out. Oh, look good even there. Okay, let's go back to our second browser. This gets really complicated fast because you have 2 or 3 browsers. You need at least 3 browsers to make this work ultimately. So I'm going to log out, log in. Yes, it's working exactly like I want, except I want this on top. Let me change that. I'm going to change this. Of course, I just reverse the order. I go data, comma, and now the most recent, whoops, the most recent message will be on top. There. Back to a second browser. There we go. So log out. There. In fact, why don't I tell everyone that someone left? That's a good idea. I'm going to say someone left. We're going to do the same thing. Let's broadcast to everyone that someone left the chat. Okay, let's go back. There it is. Okay, so we'll log out. Oh, someone left the chat. It's working. Look at this. Now, this would be useful. Let's say we had a game or a chat room. You want to know how many people are connected right now. There are 225 people connected. Oh, now there's 226. Oh, 224 now. The number of people goes up and down. You'd want to notify all the clients or the browsers what's going on the server. So this is a very common thing. You'd notify who's there and who's left and what's going on. Okay. Now I need a clear button because this is getting messy really fast. Let's go ahead and make myself a little button here. I'm going to put it right here. I'm going to call it clear. Take a look. Yeah, it'll clear my chat. I'm going to have it simply on click. I'll just say, yeah, I'll do it inline because it's pretty easy. And I'll say set messages to an empty array. Oops. That should work. Oh, look at that. Perfect. A work of software engineering genius, or at least kinda. And log in. Fantastic. We have the real workings of a nice working chat app now. So what I want to do is someone. I'm not a big fan of someone. I want to know who joined, who left the chat. So now, of course, if the person had logged in, I would have had a post for this and I'd probably set a session or a cookie, right? Now, it turns out there is no easy way for my WebSocket stuff to know this because this is inside here and reading a cookie is kind of hard here. There is a way to connect your session to the WebSockets, but we're not going to cover that today. I'll give you a copy of this code, and I've got that in the master branch. It shows you how to do that. It's not that hard. You have to simply do some tricks with the session here and then read it. But we're going to fake it for now. We're going to pretend that we know who they are, right? We just save their name, right? We would save the username in a session. Okay, this is what we'd normally do. And what we probably do is also when they connected, we'd probably get the username out of the session, wouldn't we? But we're not going to do that. We're going to fake it. Okay. And I'm going to use a little library to just generate a random name for now because I don't feel like doing anything else right now. So I'm going to include this little package that I've got, the IKEA name generator. It's kind of fun. Okay. And I'm going to just generate a random name. Let's make sure it runs and okay, let's install our IKEA name generator. So npm install IKEA name generator. It's very small. Yeah, it's nothing to it, really small. Okay, run local. And now we can generate just random names for our users. Okay, let's make a new const name equals IKEA dot get name. That's all we need. Okay. And we're going to say someone connected. We'll tell their name. We'll go name, comma. Let's take a look and see who connected. Whoa. I guess they kind of look like IKEA names. Try another one. Log out. Log in. Those are pretty complicated IKEA names. Mine are much simpler, like Bjorn. I think my sofa was called Bjorn back in college. We had a sign on them called "Don't Spill on Bjorn." No one listened. Okay, but we got some kind of name. Okay, so now I can say, welcome to the chat, and I can actually put their name plus name. And here I can make this a template literal, and I can say name join the chat. There. Or just join the chat. There. And I can also say name left the chat. I'm just generating random names. And as we know, this would probably be something different. We get it from the session. Okay, how are we doing here? Okay, this I can pronounce. Yeah, Voslo or Voslo. Okay, yeah. Just join the chat and welcome to the chat, Voslo. Yes, okay. Sounds like a great dresser. Very cool. So now I know who has joined the chat and I can send messages. I'm sending messages to all the users that, in this case, Voslo has just joined the chat. Very cool. So what else can I do? Well, what I can do now is maybe I can type in some messages. So what I do is I want to have a little input here to allow it to send messages to other users. So I have to add a bit of code to this. I'm going to have to add an input. So let me go ahead and input. Where should I put that thing? I'll put it, I think, right below my logout button here. Before, after? I'll put it after. So I'm going to make an input right about here. There should be a text area. Yeah, let's make a text area because you can type more stuff or multi-line stuff in a, so if we rename that to a text area. Yeah, it looks better. I like that. And let's make a div to make it on a separate line. There and there. Okay, kind of looking like a chat app. That clear should be, I think, down here though, shouldn't it? That should be, I think, there. Ah, much better. And how about a send button as well? I'll do nothing for now. Just say, I'll take that out for now. And we'll say send. How we doing? Okay, this is not bad. Send clear, can type stuff. Very cool. Okay. Now, as we know, as with any input, I got to hook it up, don't I? Because this doesn't work. If I just type like that, React doesn't know that I've typed anything. So what are the two things we have to add to a text area or an input, everyone? One of them is, of course, value. And the second one is on change. Now, it turns out value is not as required. You get away with not having value. You can just have on change. Okay, but you got to have your on change for sure. Okay, so I'm going to have my text area I think I can put it right here. There we go. On change equals there. And it'll be event. And I'll say, I got to save this as some state, don't I? So let me make some state there. And that's going to just be my text. So text and set text, and I'll start with an empty string. There. Okay. So now my on change for my text area is going to be set text to our old friend event.target.value. Okay. And just for fun, temporarily, let's watch what we typed. Let's put our text maybe right here. Now let's make sure we are in fact saving it. So if we type, we get our text. Great. Okay, so it's all working. I almost always do this to make sure, yes, my on change is working. I just put the text somewhere. It's only temporary. I can delete it now, just to make sure that I have in fact done that. Okay, so now I can make my send button do something. Okay, so do what? Well, on click equals on my send. Okay, I want to send, don't I? I'm going to make myself a function called send. There. Oh, very cool. Why is someone joining? Because what's happening is it's auto saving and it's re-rendering. Good question. Why does someone always join? It's not every time I type. Well, that's not going to work. There. Let's log in again. There. It's not every time I type here. It's every time I edit in here. It's updating the app and it's simply reconnecting every time. I know it's kind of aggressive, but every time I save my app, of course, it re-renders my React. Okay, let's make a function called send, and its job will be to send the text. You can probably suspect that I'm going to probably do an emit. Emit what? To my socket. So I'm going to set socket dot emit. I'm going to emit a message, and I can pick a type, and I'm going to send the text just like this. So I want to send the content of that text area out. I should give it a type. What should I call it? Well, it hasn't really got any kind of name on it. So let's call it a public message or something. I'll call it public because there's no to yet. I'm not sending to anybody. So when someone clicks, it's just going to be a public message. Okay. And that'll be my, or I can say message, of course, as well. It doesn't really matter. Let's make it message. Okay. So send a message type of message, generic name, out to our socket. Okay. Now you may have noticed my app is not very happy about this. What's my error message? It says line 23, socket is not defined. Really? 23. Well, there it is. It's right there. Why am I getting sockets not defined? I'm clearly defining a socket. So what's the problem? It's pretty obvious, right? In JavaScript, of course, socket only exists inside this use effect. It doesn't exist anyplace else, does it? Only in here. So yeah, it's out of scope. Exactly. Out of scope. So it's totally correct. There is no socket. I need something called socket. What can I do? This socket is not surviving this render. This happens once and never happens again. And this socket, it vanishes. Nobody else sees it. So there is a feature of React that allows things to survive a render. What's that called? There's a particular function we can use in React so things can survive a render. That's what it was designed for. We've talked this a few times. Yeah, state. That's the purpose of state, so stuff survives. Let's make some state. Use state, and we'll make it called socket. And set socket, we'll start off with undefined for now, is fine. There. And let's just save our socket. Set socket to our socket. There. And that may work. Now it's the same name, but it doesn't matter because this is not the same socket here. This one's the scope, but this function is being used. So now I have a socket and it looks like it's going to work too. Very cool. So now this socket is the same. This is like, remember snakes? This is the same thing. Remember we saved connection. Connection equals con. And then later on, we used connection dot write. That was how many weeks ago? That was like 20 odd weeks ago or something. We did snake server. Anyway, the same kind of concept. We save the connection, we save the socket, so we can use it later. Okay, so now my on click is going to be send. There. Okay. So hello and send. Well, didn't crash on me. Any errors? Nothing obvious. Okay, so far so good. Let's go to our server. How's it looking? Well, seems pretty happy. Nothing's happened yet. But now what? Now what do I do? What's going to happen to this message? I just emitted this message. Text. Well, now I of course have to go to the server. It has to listen for for messages, doesn't it? So my server probably should do a dot on for a message. So client is always client dot on. Listen for a message of type. What did I call it? I think I called it message, didn't I? It's kind of generic name. Yeah, I called it message. So message. And when you get one, data is as good a name as any. There. And we'll just console log. Little, we'll say name. Oops. Curly braces. There. Sent. And we'll put the, oops. Sent, and we'll put the data here. There. Okay. Name, sent, data. So we'll see what we got from this user. Go to our server. Okay, let's try and type something. Send. Oh, Alhes. They're getting easier now. Alhes sent hello. Great. Okay, let's just put a little colon there so I can see what's there. Okay. So now we're getting messages. Hello, hello, hello. Okay. But that's okay, but I don't care about the server. I want to send this to my users. I want to see how someone else here should get my hello. That's what I really want. Okay. So if I say hello, I want this user to see my hello. Well, how do I do that? Well, of course, now the server has to turn around and send that message to another user. And this is I guess it's the open secret about web apps, and particular web chat apps. Now, we've all used chat apps, haven't we? WhatsApp, WeChat, iChat, or WebChat, Face, all these chats, right? Kako Chat, all kinds of cool chats. And what happens when you click send on your message? Does it go directly to that person? Of course it doesn't. It goes to the server. The server sees the message and the server decides what to do with it. And it's, oh, this message here is for everyone. I'm going to send that message to everyone. Or this message is for this user. I'm going to send that message to that user. And that is how web chat apps always work. And if you think about it, they can't work any other way, can they? You can't get a connection from your phone to somebody else's phone. That's just not possible. Technically, could not happen, really, because the internet in between. All you have is a connection to the server that you logged into. So the server gets the message you send, it reads the message, it then decides what to do with the message, and then it sends it along to whoever that message is for. And that's how they all work. So knowing that, and knowing how the internet works, we wouldn't for a moment think that any company would take advantage of that and perhaps read our messages and use them for some kind of commercial purpose, would we? No, that would never happen, would it? No one would do that. No company would read our messages and send us ads based on what we typed. That'd be unethical. I'm sure no one does that, right? Yeah, of course they did. They all did that. And back in the early days of web chat, of course you did. You clicked to your friend, hey, let's go skiing this weekend. And a skiing ad shows up a minute later on your browser. Wow, how'd they know that? So yes, this was an unbelievably rich source of marketing information, mining these millions and millions of chat messages for all kinds of things they can send ads to. It was worth billions. So you wonder why these chat apps are free? They were making a whole bunch of money selling that information to other companies. And as we know, it was common practice. Now, that is now changed because we have what's called this end-to-end encryption, where the React app encrypts the message and the server only gets the encrypted message, so it can't read it. Only the client that it was supposed to be sent to can decrypt the message. It's called end-to-end encryption. A lot of chat apps now have that. Some don't. Some very big ones don't have that, and the server still reads every single message you send and reacts accordingly. Maybe sends you commercials, or who knows what happens. Okay. So it's gotten less, but it's still there. The server does get the message. So we read their hello. Hmm, let's read that hello. Let's send them some commercial based on hello. Okay. So now what? Well, now the server has to decide what to do. So I'm going to say, when I get a message, I'm going to send this message to everyone. In other words, I'm going to send a broadcast message to every other user. Since you didn't specify who it's to, I'm going to simply say name says, and I'll put this in here. And yes, they even have access to voice data now. Yes, if that's not encrypted, that can also be a problem. So yeah, this is a big business. This business of large or big data, collecting data about everyone. So okay, so I'm going to send to everyone. I'll send a system message because it's from the server. This person said this. Okay, let's get both of our rack opens now. Okay, let's say hello. Oh, look at this. It says, well, I can't pronounce that. It says hello. Hey, let's go to the beach. Send. Hey, just got a beach ad, right? Hey, exactly. Okay, so this is working. We have broadcast messages where, let's look at another one. Let's pick another one. Let's grab another user. We'll get 3. It kind of works best with 3. As you can see, they take up space pretty fast on your screen. So let's log this third person in. Okay, these are getting harder to pronounce. I think they've changed the library. They used to be small, now they're really complex. Okay, so let's go ahead and, hi, I just joined. Okay, and these 2 users get from that name, I need a different library. Hi, I just joined. So this is great. We now have real messaging, real time between a number of users. And if this person logs out, oh, they just left. Guess they weren't so happy with our chat. Okay. Oh, they're back. Different name. Okay, so this is working. We have real broadcast chats. So what I want to do now is, although broadcasts are fun, I want to send a message to somebody, to a specific user. So I need to be able to have maybe go there, 1, 2, 3. Oh, they're here somewhere. There. I'm going to make myself a to input here, so I can say who this message is to. So I'm going to go ahead and to my chat app, I'm going to add another input to say who this message is for. Let's put that right at the top here. So in my chat.js, let's go ahead and I'll put it, trying to think. I'll make another div because I don't feel like doing CSS. Okay, and I'll make an input. Whoops. Scary stuff. Input. There. How's it look? Okay, there we go. That's kind of my to. Okay, I don't need type equals text. That's the default. Okay. So now, but I do need a way to save that. Let's put a placeholder. Holder equals, I'll call it recipient. Is that close enough? There we go. I'll put it here too. I like the placeholders. They are kind of cool and they're not hard to do. I think I put one here too. Let's give it a try. And how does that look? Up, and I'll say, whoops, type something. There. Very cool. I need some state. It's an input. I got to have some state for it. It makes total sense. So let's go ahead and make one more state for ourselves. We'll call this 2. Who this is going to be 2. So it'll be 2 and set 2. And in our input, we'll just do the same thing as here. We'll just do the set set 2. So right here, there we go. On change equals and event and set 2 to my event dot target dot value. You memorize this pretty quick, event dot target dot value, because we use it so often in React coding. It's just second nature, event dot target dot value. Okay, now I can type. Let's quickly put a 2 here. Let's put it right here. So I can see my 2 being typed. I always like to do this to see, is it in fact working? It is. Great. Okay. So I don't do that 2 anymore. Okay, so now I can type a recipient. So now looking at my 3, where'd they go? 1, 2, 3. For example, I could send a message to, that's really hard, to that recipient. And I can go, hey, there, what's up? There, okay. But of course, it doesn't work yet because everyone's getting the message. I need to somehow identify that this is who I want to send this message to. So I'm going to make a quick change to my send function. And I'm going to have it add the 2. So let's go here to our send. Right now we're just sending text with no 2. So I'm going to simply change this. And instead of sending just text now, I'm going to send an object. You can send objects also over your Socket.io emits. And I'll include the 2 as well. So 2 and the text. Okay, that's it. No need to use your array map over it. No, we're just sending. That's it. Okay, this is the client app just telling the server who this message is for. So now if I send this, my server now, let's go to the bottom, take a look. Oh, double check and nope, it's fine. And now we are sending an object socket emit type message, which contains both the 2 and the text. Let's go here. Okay, let's try and send something now. Okay, it sent an object. That's not bad. I'm gonna, when you do a console log, sometimes it doesn't. I could probably do a convert to JSON, but I'm not gonna do that. I'm just gonna maybe make it 2 lines instead. There we go. Let's say console log data there. When you put an object inside a template literal like this, you just get object. Right? Just one of those quirks of how it works. Instead, I'll just put this here. Sent there. Something, and I'll console log the data here. Just like that. There. Okay. So now we click our send again, and we should see what got sent. Look at that. Now the server received an object. Cool. Now, of course, Reacts, they can't render. We just get object. So, of course, now our client now has to understand it's now getting an object instead. Or I can have my server decode that, which is what I'm going to do. So now, every time someone sends a message, it's going to be an object. So I need to now send data dot text. Okay. There you all go. One more. There it is. Okay. Okay. So everyone gets the message, of course, but it's still not making it to the right person, is it? It's still sending to everyone. It says, GGC says, hey, wow, what's up? Okay. So now I need to have some way my server to find out, where do I send this message? I clearly don't want to do a broadcast emit, do I? If there's a to, in other words, I have a to, I want to be able to know that. Let's go const. In fact, we can this. We can say to comma text equals data. We can destructure that data there. And we just say text again there. Okay. But we want to send to somebody. So what I'm going to do is I'm going to say if there's no to. So if not to, if there is no recipient, then just send to everyone. How's that? But if there is a to, then we'll do something else. Fair enough. Let's go to our three apps. We'll go there, there. Let's do, and I'm going to send to that for now. See, so clear, 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 no sender. There. So send. Okay, it works. I had no recipient, so it's sent to everyone because my server says that. If there's no to, then send to everyone. Let's now add a recipient. And back there. And no one gets it, which makes sense because I'm not doing anything yet. So now I have a problem. How do I send or emit to a specific user? In other words, I need their socket, don't I? But I haven't got that. Now, I can't use my socket ID because if I do client.broadcast to myself or send to myself, I'm just going to send a message back to me. And that's not going to work. I want to send to another client. But I don't have another client. All I have is me. All I have is my code here. And all I know is who I am or who this client is. I don't know anything about any other user. So what can I do? Well, a couple things. We've got this client ID thing right here. So knowing the client ID of any other client, you can reconstruct their socket or their client object. That's useful. But now I need the client ID. I still haven't got client IDs. I need to maybe maintain a list of all the connected client IDs. And that's what I'm going to do. I'm just going to save a list because there is a point in time where I know the client ID of everyone who connects. It's right here. When anybody connects, I know both their name and their client ID. So if I can save their name and their client ID, I can then look up by name and get their client ID again. And JavaScript has a very useful type of artifact that is custom made just for this. What would that be? What is custom made to do lookups in JavaScript? We'll call it users. What should we use? Now it's JavaScript. It's pretty limited choices. There's only a couple things we can do, right? Would it be an array? Well, arrays don't do lookups. You have to search them. An object, yeah, we could use an object. Users. Okay. And it's going to contain the name and the ID ultimately, right? That's what I want. Okay. So let's do the initial plumbing. When somebody connects, let's add them to our users. So we'll say users name equals client dot ID. And we're going to console log users. Just every time somebody connects, we're going to console log users. Okay. And when they disconnect, let's remove them from the users, just so we keep things nice and clean. Okay, so when they disconnect, where's it? Right there, we will just delete users, name, and we'll also console log users. Fair enough. Let's go take a look. Okay. Oh, and user on line 25, I've got an S. Yes, users. There we go. Well, that looks like something. Oh, look at that. So now I have 3 users. Let's log somebody out. And now I have 2. Let's log them back in. Now I have 3. And now they have a different client ID. Okay. So now I can, given any user's name, I can find their client ID. And this is exactly what I need. Okay, so now I can go ahead and I can convert this to a client object. And there's a function in socket.io called to, io.to, and you give it a client ID. So if it takes some kind of ID, it will convert that to an actual socket object that you can do an emit on. So I need to get the client ID. So let's go ahead and go const our to ID equals our users. And we have this to string, the name of the person right there. There's our to ID. And now we can say io.to this to ID. Okay. And that allows us to convert that to an object when we can go dot emit and we can send a message to this. We're going to call this we'll call it a message type for now. We might want to call this maybe a private message, give it a different kind of name so it can be rendered differently on the screen, perhaps. Maybe system messages are in the corner in green, maybe public message or someplace else, and private, who knows? We can do all kinds of cool things. For now, I'll just call it a message as well. Okay. Okay. And let's go ahead and we're going to send a message. Now, I'll probably just do this, although I could probably send the object back along and have the client decode it. For now, I'm going to be lazy and just do this directly. Just send text. Okay. We are not listening to messages of type message on the client side. So easy enough. We're going to go ahead and listen to message events. Remember I mentioned that everything you do on one side, you have to do on the other side. It's very easy to forget. Okay, let's try it again. 1, 2, and there. Let's take this user. Let's go ahead. I might as well give them the right name, be polite. Oh, take a look. Undefined. Oh, okay. Looks like it couldn't find that. Let's take a look. And oh, you're right. Yeah, space. Oh, got to do a trim. Oh, there we go. We got our message. Now one person gets all the messages and the middle person doesn't. Let's change and send a message to this person. I really should add a trim, shouldn't I? There. Look at this. Now we have really what appears to be user-to-user chat, which of course we know is fake. It's going through the server, but it does work. And now, yes, everything's working. So this is the way it's commonly done. We would keep some kind of object that would track all of our users and simply use that. It's the easiest way. There are other ways. You can actually have socket.io query and ask it who are the connected users, but it turns out that's actually hard and it's asynchronous. So we almost always just make ourselves a make ourselves an object and query it that way. Okay, so I will release the code to this app. I've actually got one that has a few extra features, like a notification. I've got a copy in the master, and by the way, this code has a master branch, and it plays, I think, a Samsung whistle when a message comes in. It's kind of cool. And you guys can give it a try. You're welcome to use WebSockets in your final project. It is part of the curriculum. We do have that as some stretch material. So, and it's really not hard to use. WebSockets are super fun to use, and they really add that sense of real time to your web apps. All right, everyone, that's our talk for today. Thank you for coming, and I'll see everyone again next week. We have another advanced lecture. We're going to pick something different. I think next week we're going to do containers.